All right, graphing quadratic functions in standard form. Remember, standard form is f of x equals ax squared plus bx plus c. We always want them to be in order because that will help us make sure that we are doing our right coefficients or constants. All right, so steps to graphing quadratic functions in standard form, not vertex form. First thing we need to determine is which way our parabola is facing. This is going to be the same as what we did with vertex form, where we're looking for our value for a. So if a is positive, our parabola is facing up. And if a is negative, our parabola is facing down. Remember, if our a value is positive and we're facing up, this means that we have a minimum. And if a is negative and we're facing down, that means we have a maximum. All right, determining the axis of symmetry and the vertex of the parabola. Here we have a little bit more work than when we looked at vertex form. So the axis of symmetry is going to be the equation x equals negative b over 2a. And the vertex is going to be that same x value, negative b over 2a. And then to find the y value, we're going to plug x back in to our function. So that vertex notation looks different and more difficult, but really we're just plugging x in. Plug x into f of x. Okay, find any x-intercepts by solving f of x equals 0. The function's real zeros are those x-intercepts. The methods that we use to solve a quadratic, remember, are to AC factor. Or we can use the quadratic formula. Which, remember, just for note's sake, I'm going to rewrite it for you. We have x equals negative b plus or minus the square root of b squared minus 4ac. All over 2a. And then our y-intercept, we're going to find f of 0. Now the nice thing about this is when we find f of 0, we would have a times 0 squared plus b times 0 plus c. But if we simplify this expression, 0 squared times a is still 0, so that can cancel. B times 0 cancels, so we're just left with c, or the constant. So our y-intercept, we can really just look at our standard form to find it. Then we're going to plot those points, use our axis of symmetry to find additional points if necessary, and then remember we're going to connect with a curved line to make that parabola shape. So this first one, consider the function negative 2x squared plus 16x minus 5 without graphing. Determine where the function has a minimum or maximum value. So what is our value for a? A equals negative 2. We know that that means that our graph is facing down, which means we have a topmost point, which means we have a maximum. Find that minimum or maximum value and determine where it occurs. So if we want to find that maximum value, this is going to be the y value, and where it occurs is the x. So we're going to start off by finding x equals, using our formula, negative b over 2a. if you need to, up here at the beginning, state what your a, b, and c equal. A equals -2, b equals 16, and c is -5. So if we plug in what we know, we now have -16 divided by 2 times -2. 2 times -2 is -4. And -16 divided by -4 is +4. Now we're going to plug that back in to find our y value. So f of 4, so we have -2 times 4 squared plus 16 times 4 minus 5. I recommend you plug this whole thing in your calculator at once, but you would get -32 plus 64 minus 5, which is going to be 27. So, if we go back and actually answer the question, our maximum value is 27 at x equals 4. Okay. So if we find our domain and range, we know the domain of a parabola is -infinity to +infinity. And we know our range. We know we are facing down. So we're going to start at -infinity, and that maximum value we just found was 27. So we have -infinity to 27.